This is a presentation made by ESET Team 1E. A population's health is directly related to the environment they live in. Each year, more than 2.4 million people die from health problems related to air pollution. Most of the pollutants that cause health problems are usually elements that are found naturally in the atmosphere but at much lower concentrations. So it is the high concentrations of substances that prove to be harmful, not the mere presence of them. This means that in order to prevent health issues from arising due to bad air quality, the concentration standards of the elements present in the air of a room or an outside ambient must be similar to the ones found in the atmosphere. This can be achieved by monitoring regularly the air quality of the air and by using preventative and remediation techniques to keep levels of harmful substances as low as possible.
We start by stating that the pollution can be defined as the addition of any form of substance or energy into the environment at a rate faster than it can be dispersed, diluted, recycled, or stored in some harmless form. With this in mind, we can say that the indoor pollutants of air would be ozone, carbon monoxide, mold and mildew, asbestos, and lead. We do not consider a CO2 to be a pollutant. Some of the sources of identified indoor pollutants would be laser printers and copiers for the ozone, damp areas like leaks for mold and mildew, deterioration of the building for its composition for asbestos and lead. Having the said pollutants in the presence of air of an enclosed area can bring negative impacts to the health of those who inhabit or work in the room. Each pollutant has their own individual impact on health. Ozone causes respiratory problems, irritation and swelling of the airways, and asthma. Lead can lead to bone, kidneys, immune system, and nervous system problems. Asbestos, a long exposure to it can increase chances of suffering from lung cancer. Mold and mildew, this can cause respiratory ailments like asthma, bronchitis, alveolitis. Carbon monoxide can lead to headaches, breathlessness, and also dizziness and tiredness. The term sick building syndrome is used to describe a group of symptoms caused by exposure to indoor air pollutants in poorly ventilated areas. The symptoms include headaches, irritation of eyes, nausea, coughing, sneezing, drowsiness, fatigue, nose drought, and irritation. Some of the pollutants that are important to consider in the outdoor areas are sulfur oxide, nitrogen oxide, carbon monoxide, carbon dioxide, and PM1, PM2.5, and PM10. All these pollutants are released into the environment in several ways. For example, human activities such as industrial, transport and farming, and also normal biological processes like forest fire and decomposition of organic compounds. Outdoor air pollution causes substantial morbidity and mortality. It can affect both the respiratory system and the cardiovascular system, triggering asthma, cardiac failure, pulmonary diseases, and chronic obstructive.
A questionnaire was applied to the workers of the room DBO10 of the Beister building. The average result of the questionnaire indicates that the symptoms that they were suffering from were headaches, dizziness, irritation of eyes, and tiredness. According to the interviews that were developed with the employees that work in the Beister building, we could vaguely assume that their complaints were related to their poor air quality of both the room they work in and their outside environment. The lack of fresh air and the proper poorly ventilation system that could be the culprit. For the area surrounding the Beiser building, it is very likely that the transit of cars and other vehicles lowers the significance of the quality of the air because of the emission that the car's exhaust pipe release into the environment. Certain materials used in a certain manner are necessary in order to obtain data that could be analyzed. It was decided that in order to get sufficient information to understand the causes of the complaints that were presented were CO2 levels, the temperature, and the humidity would be measured in the indoor area of the Beister building. Three different devices were used to get the measurements. This is a carbon device measurement. The measurement were done over a 3-week period with a machine running 24 hours a day and storing information every 5 minutes. The device works by shooting out infrared radiation into the air. The CO2 within the office absorbs the infrared radiation that the source sends out. The more CO2 present in the air, the more infrared will be absorbed. The data is then stored in the data logger. A black USB device is the temperature and humidity measurement device. It was used for a week to observe the office air in the Baser Building Room DBO10, where it took recordings of the temperature and humidity in the room. It works in a similar manner as the CO2 machine. A yellow machine was also used to analyze to scope out the measurement of the room assigned.
As for the outer area of the particulate matter 10, and temperature levels would be measured. The gray box shown on the picture are two air boxes located on lampposts outside the 61 and 63 building. These measure everything from PM, ozone, humidity, and temperature. They have a minute average and collect data for 17 days to see if there were any connections between the weather and the PM concentrations. The second device is used to measure PM. It is known as a Casella Cell Microdust Pro Aerosol Monitoring System, or better known as a PM device. The device works by measuring the levels of particulate matter concentration in a real time in micrograms over cubic meter. The machine uses a modulated beam of infrared light projected into a measurement chamber. When the dust particles enter this chamber, they scatter the infrared light to the receiver, and if there were no presence of dust particles, all light would be prevented from reaching the receiver. For these, 3 measurements were made. The first one is the difference in PM emissions between an old car and a new car. The second one is the effect that a screen has on air quality in front and behind of it. Here we can see the PM machine recording in front of the screen. The third experiment was to measure car traffic during a 4-hour period and see the peaks in air quality.
The results for indoor showed that the CO2 levels were measured in the room were average of at an 800 parts per million. But it shows a decrease in levels of CO2 when the room is vacated for a long period of time. It decreases to an average of 310 to 250 parts per million during the evening. The third measurement done was to differentiate the CO2 concentrations between the Beister building and the CO2 in a classroom. The CO2 concentrations gathered from the experiment conclude that opening windows for a small period of time reduces the ppm of CO2 considerably from the room part per million of 1,600 to 340 parts per million of CO2 within a 2-hour period.
As for outdoors conclusion, the new cars reduce about 97% the PM, the screen about 31% difference, and the humidity and temperature, even though we think they affect them, it is not as important as the amount of vehicles and type of vehicle passing through the area.
The indoor experimentation project uses carbon dioxide as a detector of air quality because most heating and ventilation systems actually recirculate the indoor air along with some input air from the outside to reduce heating and cooling costs. Since in an office space carbon dioxide does not spontaneously occur, the amount of CO2 in a workplace is therefore due to the people and the things in the room, as some appliances, as previously mentioned, do produce a small amount of carbon dioxide. The air quality would thus be proportional to the amount of people in the room and inversely proportional to the quality of the room's ventilation. During the entire experimentation stage, the staff of the Beister building has informed the Indoor ESET 1E team that they are replacing the old ventilation. The air quality in the room, but even without the ventilation, the air quality in the room is above average. Of course, excluding after office hours. The symptoms they experience may be attributed to the high peaks of CO2 at around lunchtime, but no other data may indicate otherwise that it is the CO2 that is the culprit. Another factor that could be causing the employees' discomfort is the temperature and the humidity of the room they are in. An average of 23 degrees is a comfortable temperature, but in combination with the humidity and the carbon dioxide concentration, it can be difficult to breathe. This is because carbon dioxide, along with other gases that make up the air, obey the ideal gas law. Because of this law, CO2 in the room, along with the other gases, will begin to expand due to heat. As CO2 quickly becomes the dominant gas in the room, it becomes more difficult to breathe. Thus, it is not only carbon dioxide concentration to blame, but also temperature and the humidity.
Humidity and temperature have a different effect in the amounts of PM1, PM2.5, and PM10, which is the presence in a place. But the main cause of the variations of PM are because of the amount of vehicles and the type of vehicles passing through the area. Also, the use of a screen does in fact reduce PM concentrations in front of the screen and behind the screen, keeping these areas, preventing the PM from spreading to people, plants, and animals. Also, according to the data collected, the difference is about 31% in PM concentrations. Finally, the new laws regulations that were made for the cars do in fact help reduce drastically the emissions. The difference between PM emissions in the new car and the old car was about 97%.
The indoor group advised reducing the amount of people in the room by half of the amount will reduce considerably the CO2 concentration. An alternative, reducing the amount of people in the room could not be accomplished would be to open the windows 4 times a day for at least 14 to 20 minutes depending on the weather. By doing this, the CO2 concentration would decrease. A third alternative would be to work with the doors open so that it would decrease the CO2 concentration. A fourth alternative would be a combination of opening the windows and the doors when employees are present in the room would be more effective, decreasing the amount of CO2 by an estimation of 65%. The fifth alternative to reducing the limit of CO2 in an indoor space is to introduce ventilation system or even plants.
The outdoor advice we can give is some that don't require much effort would be to not go outside or really close to the streets during peak hour, since this is when the air quality is the worst. Second, the more amount of vehicles, the more amount of emissions, so using different transports such as bikes or skateboards can help. Also, there are more drastic recommendations which can be given. These, however, require much more effort. One could be to not allow unfiltered cars near or around the Beister. This would reduce drastically the amount of PM. However, many old car users don't want to switch to a new one. Second, if not bothered by aesthetics, they can implement the use of 1 or 2 screens around the building, which will reduce noise and will also reduce PM concentrations. The only disadvantage with this would be the view. A third option would be to plant high bushes or high trees, which would absorb and clean the air. This, however, would affect visibility and it may have a large amount of money to do it. Thank you for your time.